Great. So it's 12 o'clock, uh, and I'm delighted to be introducing Diane Hubbard of Green Footsteps. She has a practice, Footsteps. She started off as an engineer, and today she's going to be talking about baselining of existing buildings. And I have a few words to say about the introduction to that. She says relatively few UK dwellings are currently benchmarked pre-retrofit, and that means assumptions are made by specifiers regarding how the building currently performs, which may or may not reflect actual performance of the building. So this may result in unintended consequences and client disappointment. So Diane will be examining the assumptions made about existing buildings, drawing from her wide experience of testing hundreds of existing buildings of all ages. Thank you very much, Diane. Welcome.
Great, thanks very much, Tim. I hope that you'll find this presentation interesting. It's sort of a
Oh,
potted, sorry.
may I just add, the Q&A, if anyone has any questions, we'll be answering them at the end. And if people could put the questions in the question and answer rather than the chat, that would be really helpful. Great. Sorry.
No
Over to you,
problem, Tim.
Diane.
Okay, cheers, Tim. Okay, so yeah, so what I'm trying to do is sort of offer you an overview today of why we should really be looking at our existing buildings before we start retrofits, because of the level of unintended consequences that might be incurred if we don't examine that as a factor. Okay, so in terms of broadly what I'm going to be covering, I'm going to be looking at the impact of air tightness on energy use. Going to be talking quite a bit about EPCs, and I'm sure most of you are aware of the impending change in the existing dwelling EPC software to RDSAP 10, which is going to take place within the next month. So I'm going to talk a little bit about that, a little bit about unintended consequences, and then really thinking about the strategy for retrofit in general. But the focus is we're talking air tightness here. The presentation should take about 30 minutes, so there's then ample time for questions at the end. It's easier to really maybe cover specifics that people want to talk about on certain things, but hopefully the presentation itself will give you an overview. Just want to flag up that I have a real drive with this topic because I do feel it's so important from so many points of view. Whether you're looking at an individual dwelling that's going to undergo retrofit, whether that's your own home or a client's home, or whether we're looking at stuff under past 2035, large scale items. I'm really concerned about the assumptions that are made where the buildings might be in terms of air tightness and what those consequences may be. So it's appropriate for whatever your background, really. I have developed, based on my experience of testing the buildings and how important I see this subject to be, you'll see that there's two logos at the bottom there. One is Green Footsteps, which is my consultancy that I've operated for a number of years. But you'll also see something called Home Energy Doctor, which relates to, I really strongly feel we need to transform the air tightness testing industry to really enable it to be used as a tool from an energy efficiency point of view, rather than just for certification of particularly new build dwellings. And so that's what Home Energy Doctor is all about. And it's about training people to understand what existing buildings are all about. Okay, so, well, how important is air tightness on existing buildings? The example I've got put up on screen is an example of a deep retrofit, which is to the AACB retrofit standard. You can see there's been significant changes in the property. We've got a before and after photo on here. And just looking at the numbers side of it, you'll see that the building was taken from an air tightness point of view, from an air permeability of 9.1 to a post retrofit of 0.5. But the reason I'm including this example here is really the impact of the air tightness on the energy use of the building. Now, clearly there was lots of work done to this building, but if attention hadn't been paid to the air tightness in the way that it had, there would have been dramatic implications for the energy use of that building. So, you know, one of the very sad situations that comes up quite often, unfortunately, I have to deal with is I think people think there is an air tightness fairy when we're looking at retrofit. And the air tightness is just going to happen when you put insulation into buildings. And clearly, I'm assuming the audience is quite well informed about, you know, how air tightness should be delivered in retrofit. But there is quite a reasonable number of properties that cross my threshold where people haven't paid that attention that is needed. And you know, if simply the air tightness was maintained at the level it was tested, 9.1 as an air permeability, and not reduced to, not improved to the level of the final test, which was an air permeability of 0.5, there would be dramatic implications for the energy use. You know, we're talking about doubling the energy use of the building, but this clearly is not a, you know, a more typical retrofit where you're doing it on a tight budget, you're not able to do everything. You've really got to focus on what you're actually able to do. So if we think maybe more about a wider range of buildings. Now, I've had the, you know, I've been very fortunate. You know, my original academic research area is pre-1900 houses, and I've been very fortunate to test hundreds of existing buildings, a small selection of some of them here. And, you know, my original research, the thing I identified that the assumptions that were being made, and generally, I won't say the general population, but the well-informed professionals within the industry were making assumptions about what the air tightness of buildings was pre-retrofit. And, you know, those assumptions can be wrong. And I just want to explore things in a bit more detail. Now, in terms of what we have as a, our sort of formal knowledge on air tightness in existing buildings at the moment is really relates to this paper cited here, which is Stephen, which goes back to 2000, which was a meta-analysis of all the existing buildings that existing dwellings that could be identified at the time of that study, as far as I understand. And that has a mean of about an air permeability of about 11.5. But you can see from the sort of vaguely normal distribution that we've got on there, we've clearly got, you know, within, you know, around that figure of 11.5, you've got a wide range of air tightnesses. And this particular study it wasn't particularly age related. It covered a whole range of property ages, significant number of pre-1900 houses up to sort of the late 1990s. So we've got a whole range of properties within there. It's unknown as to what state those properties were actually in at the point the test was carried out. But this at the moment sort of stands at the our best knowledge that we have. My own work that I've done, which I would like to publish in the future, collates the tests that I've carried out. I've been quite systematic about how I do those, working to the appropriate defined standards. So, and I clearly have quite a lot of data available, similar number to this study as a whole. So, but this is the best published information that we currently have. So we can see that within that, you could have a property that is 25 and you could have a property that's 2. So what have you actually got? You know, what can it be assumed that you have? You know, if you are an architect designing a retrofit, what do you actually assume the air permeability of that property should be? Or the air change rate if you're doing it in PHPP? What can you assume? So it's quite difficult, really, isn't it? Because the other factor that is coming in is EPCs. Now, if you're doing an individual client's property, they may not be that interested in the energy performance certificate. But if you're looking at, say, social housing, the driver is the energy performance certificate. It's got to achieve a particular rating. If it's private rented property, you've got that, you know, we know what it's likely to change to, you know, in the not too distant future. So EPCs really come under close focus. But, you know, what are the issues when we're looking at air tightness and energy performance certificates? You know, we're looking at average data that feeds into it. And what if your property isn't average? So let's have a quick look at RDSAP 10. So just sort of backtracking a little bit for people who are perhaps not as familiar with this situation. So at the moment, you could, for example, do a deep retrofit, say AECB retrofit standard. You could be getting an air tightness that is very respectable. It may be an air permeability of 2 or better. It could be significantly better than that. It could have MVHR and very high levels of insulation. And at the moment, under the current EPC software, you cannot input an air tightness into that energy performance certificate. So it's quite frustrating that you could be not achieving the rating, the EPC rating that property deserves. And for example, under the current EPC software, something like MVHR has a negative impact on the EPC rating. Now, the new software is coming in for existing dwellings on the 15th of June. And this is RDSAP 10. We're currently under RDSAP 9.94. So how does RDSAP 10 change how air tightness is viewed in existing buildings? And is it now going to be taken properly into account in the rating of the property? Now, the really good news is lots of the issues that have been present in relation to EPC ratings on existing dwellings are being addressed. That's great, really great news that is happening. In terms of an air tightness result, you can now take that into account in the EPC rating, which is absolutely brilliant. Okay, so you know, broadly speaking, it was, you know, under 9.94, you were probably looking at an air permeability of about 15 was what it was assuming. So if you've done a deep retrofit and you're down at sort of an air permeability of 2, if you've improved it by that, you're going to get some reflection of that in the EPC rating. And what I'd like to do now is to just look at a little bit of detail in of the calculation in RDSAP 10. Okay, so it's really following a little bit more closely the full SAP software. So you can input the number of intermittent extracts and other devices, really. So you can take that into account in the rating. As I mentioned before, you can take into account if a test has been certified. But if you haven't had a test done, what happens is, what this slide shows is the calculation that is displayed. This is extracted directly from the RDSAP 10 specification published in February last year. So we've got a breakdown of the factors that are taken into account and how they are taken into account under RDSAP 10. So we've got a combination of the number of stories of the building. We've got what is it constructed of, broadly speaking. Have we got suspended ground floors? Is it a draft lobby? Are windows draft proofed? Okay, and that comes up with sort of a summary figure for the infiltration rate there that can be added to the deliberate ventilation. Now, if you have a test result, and we're talking about a certified test result here, so it's one that's been formally tested and lodged according to the correct protocol, you can input it into the energy performance certificate. So what we're seeing here are the boxes that are in effect completed as you go through the process, as the process is gone through. Clearly, this is happening behind the scenes and out of the hands of the domestic energy assessor who's actually doing the processing. You would need to supply them with the certified test certificate. But what I want to highlight here is the little bit of confusion that there is with air change rates and air permeability in RDSAP. So if I can just draw your attention to this particular calculation here. And what that calculation is basically saying is, if you've got a certified test result and air permeability, let's assume it's a blower door air permeability. What RDSAP 10 is asking you to then do is divide it by 20 and then add the air change rate from the deliberate ventilation. So you've got an air permeability that is at 50 pascals, which is then corrected back to normal pressure. And then you've got an air change rate added to it. So we've got within SAP, we've got a confusion between a couple of things there. We've got the fact that we're mixing our units. We've got an air permeability, which relates to surface area, and an air change rate, which relates to the volume of the building, but we're ignoring the fact that they're different units, and we're putting them together. Okay, now, if you've got a nice cuboid passive house building, that ain't going to be a problem. But if you've got something like a bungalow, an L-shaped bungalow, they're going, you know, if you switch between air change rate and air permeability, you're going to have different, they're going to be different sorts of numbers. Okay, so we're mixing our units, the units are mixed there. And the divide by 20 rule that is used here to change it from an air permeability 50 pascals to normal pressure is that's quite a crude rule of thumb. And when you actually look into the background to that, it's quite I'm trying to pick what the right word is. It's based on information, an investigation that was carried out in the 70s or 80s on not many dwellings. And, you know, it isn't a straight 1 to 20 rule because it depends on the level of exposure of the building as well. So we've got a couple of factors there in that calculation, which mean that, you know, this 1 to 20, we divide by 20 rule, and this mixing of units means that, you know, we are building some inaccuracies into it. Let me put it that way. So here's an example of a building, a property that I tested. Actually, I've tested it in the last month. Okay. It's actually social housing. It's a converted church. Okay. And I'm just trying to use it to illustrate the impact of that calculation. Now, what RDSAP 10 says, it is if you've got a certified test result, you should, you know, you can use it. Okay. But looking at the impact that has, if I hadn't tested that building, if there hadn't been a certificate produced, then RDSAP 10 would assume the air change rate at normal pressure on that building was just over 0.5. Okay. But using the certified test result on that building, the figure comes out at 0.27. Okay. Now you can say, well, that's an exceptionally airtight property, really. It's a ground floor flat, corner flat. It was converted in the late 1990s. It's not a particularly high spec. They have issues within that building. You'd say, well, it's a crazy low figure, but actually, it's not. It isn't. You know, I mean, I've tested a wide range of buildings, and people make assumptions that it would be that property would be about 10 probably as an air permeability. But I just wanted to show you the difference that makes. So there's a plus side to being able to put air tightness tests in, and there's we can get a positive impact on the rating, but it really, RDSAT10, some of the calculation itself that it uses can create potentially some issues. In this particular property, they do have, there are some issues, and I've logged conditions in that property, and there definitely are RH issues, and there are some mold issues in that property. It's standard intermittent extract, and something has got to be done more formally about the ventilation itself. So, but I'm using it as an example in this instance to say there is quite a difference between what comes from a certified test in terms of the air change rate and what RDSAT10's assumptions are in terms of the ventilation rate. One question that will probably come up is what is the right ventilation rate? And that's a whole different presentation. So I hope that what is coming over is that actually we've got to be really quite careful about where the building is actually sitting. When we're looking at how people, perhaps how a budget retrofit may take place, we want to spend our money on the most appropriate things. We want to minimize unintended consequences. So surely we should understand where the building is to start off with. So I've got 3 examples on the bottom of this slide to sort of, I suppose, illustrate the issue. And I'm sure if I was able to ask you which one of these properties you thought was the worst, I think I know which one you'd probably pick. So we've got a Grade 2 listed, I think it's 18th century cottage on the left-hand side. We've got a late 1950s semi in the middle, and then we've got a 1960s bungalow on the right-hand side. Now, I'm presuming because you're well-informed people, there's probably quite a few passive house guys out there. We've got a bungalow on the right-hand side. That is going to be, it's got a large surface area compared to the volume. So it's probably got, the air permeability will be reasonable because it's got this big surface area compared to the volume. And you sort of be right on that one. I mean, the pre-retrofit air tightness result on the property on the right was 3.5, the 1960s bungalow. Okay, so that's pre-retrofit, not post-retrofit. It was built by a builder for his own occupation and had been built quite carefully. So we've got a good baseline there. But again, a general assumption would be probably that building would be 8 or 10. It's got a large surface area, so 8-ish maybe, but perhaps more likely, if you were designing a retrofit, you'd perhaps assume it was going to be 10. So let's go to the listed cottage on the left-hand side. Now, people would assume that would be worse than 10. Yeah, no question. Oh, it's an old building, isn't it? That has an air permeability pre-retrofit of 6.8. Okay. So, I think that would generally be considered that's a good level of air tightness. From my point of view, I've tested tens of older pre-1900 buildings that have that sort of level of air tightness in it. Some of it was suspended floors, so not all solid floors, but it still had a good level of air tightness. Now, the one in the middle, 1950s, now that would be definitely assumed to be about 10. Sadly not. The air permeability on that building was 20. It was suspended floors throughout, and basically the extension on the rear was a particular issue for that building, and really should really form the focus of the retrofit. But you know, hopefully those three examples sort of show what we've got to be really careful about in terms of our assumptions on how we think the building is going to perform. So what are the risks? So, you know, one of the biggest concerns, particularly perhaps where you're looking at rented properties, are the unintended consequences. You know, where we have a poor level of baseline air tightness, for example, that property in the middle on that last slide, you know, if we assume the performance as, say, a specifier, if we assume the performance is better than it actually is, then we're missing the opportunity for some probably really straightforward and relatively cost-effective air tightness measures being missed. So things like, you know, around services, I would call them super draft proofing. So not windows and doors, but things like we're talking about, you know, holes have been left in things, or routes that have really been overlooked, but really cost-effective things to do something with. But they aren't highlighted if we don't test the building. And so we miss that opportunity to deal with those, and they may still be present post retrofit. It depends on the depth of the retrofit and the budget. We could be talking something here about, you know, somebody able to spend a few £100 through to, you know, several £1,000s, you know, as opposed to a deep retrofit where we're doing everything. We've really got to be careful that, you know, we spend the money in the most appropriate way. What is the most cost-effective thing to do? We have the other side of things, like the example I've shown you in that converted building, where we've got a better baseline level of air tightness than expected. And we have to be really careful there about the unintended consequences in terms of mold or the ventilation that's going to be specified being inappropriate. You know, to not being effective enough. You know, in that particular property, we're really looking at heat MVHR of some kind being effective, and being required really to make sure that the ventilation levels are appropriate. So there are risks both ways, whether the building is worse in terms of the baseline air tightness assumed, or it actually has a more airtight result. Okay, so these are really examples of what I'm talking about there. So you'll recognize the one on the top right-hand corner already. So I don't need to, that is the building that we looked at before, where we've got, you know, an air permeability of about 20 on that building. But, you know, we've got some other examples here. So, you know, these properties are sort of 3-4 bedroom properties. The one in the bottom right-hand corner is a detached building. But, you know, I suppose what I'm trying to do is to challenge preconceptions, really, of what we've got. So, you know, top left-hand corner, you know, 60s, not a good period for building, really. But that has an air permeability of 5.8 pre-retrofit. But, you know, you compare the two top photographs there, and they would generally be assumed to have the same air tightness, and one is below 6 and the other is 20. In terms of the lower ones, on the bottom left-hand side, we've got, this is an end back-to-back property. sort of mid-late 19th century. The pre-retrofit test on that one, the property has a cellar, but the pre-retrofit test on that one came out at 7.8. And again, you know, in terms of what might be assumed for that building, it would definitely be on the upper side of 10 would generally be assumed for that building. The one on the right is actually a detached property, and that came out at 6.7 as an air permeability. So, you know, we have to sort of question our assumptions on this. And I think when I first started testing existing buildings, I assumed there would be a clear pattern. And, you know, more than a decade or 15 years, actually, time flies, on. The thing I've realised is that there isn't, unless you're looking at stock that has been constructed at the same time by the same people and has been treated in the same way since. So if you're looking at, say, social housing stock, you may be able to, you know, within a particular archetype, have a clearer picture. But if you're looking at the owner-occupied stock, you really, really have to test. And the thing that delivers actually is it gives you confidence as a specifier that you know you are doing the right things, because otherwise it's guesswork. And I don't think that, yeah, it's just guesswork. Okay, so in terms of the basic steps that we're talking about, I know this is quite basic, sorry. I tend to find, because I spend my winter doing these tests literally daily. The thing that I find comes up most is people not being clear about what the objectives are, whether that's the client or the specifier. What are you actually trying to achieve with this? Clearly, it's not clear unless you test it what you've actually got. What is the air tightness of the building? You know, you can look at sort of what the U values and the walls and things are, and you know, there's a reasonable level of understanding on those now. But in terms of the air tightness, it really can vary so substantially, and the impact of that does depend on what you're doing as a retrofit. You could argue that if you're doing NFIT or AECB retrofit standard, it's maybe less important, but most people are not in that game. They have a limited budget and they're trying to work out where they're going to get the best return, or you know, what they're going to get the best return from. And by testing it, you can work out where they are on the where that building is on the spectrum, and therefore what the focus should actually be. You spend the money on the most appropriate item. And, you know, above all of this, you know, there's a danger that, you know, those objectives, that when you've worked out what they are, you need to try and put some numbers on them. I barely mentioned PHPP in all of this. I've mentioned SAP quite a bit, but, you know, trying to quantify a number, an air tightness, you know, what are you trying to hit in terms of an N50, makes it so much easier to communicate both with clients, with other professionals, and with contractors. Putting a number on what those objectives are and testing the building are key to making sure that the retrofit performs. So I didn't really introduce myself properly there, but that's my background, and I think that is about it.
Well, thank you very much, Diane. That's been very interesting. And there are a few questions.
Good.
So first thing is, someone asks, is there any form of EPC or or SAP, is any form of EPC or SAP relevant when PHP is a more comprehensive and accurate energy modeling tool? You're just coming to it at the end of the talk there, and should be recognized as the retrofit standard for energy rating. And they say the EPC is a useless, well, it's not me saying this, this is the
Of
EPC
course
is a
not. Of
useless
course not,
tool
Tim.
and should be discontinued as standard. Well, that's their opinion. And
Okay.
I think we could also say that SAP was intended for a slightly different purpose than detailed energy modeling of a building. It was intended for something else. But Dan, what have you got to say about that?
Yeah, I think we have to work within the system that we're presented with. Having sacrificed 2 years of my life in trying to get an aspect of SAP changed in relation to open flues, right? I know whoever the person asking the question is, I understand it completely, right? I am incredibly frustrated with the methodology, as a SAP methodology, and its inaccuracies. But the thing is that that's what we've got, guys. Okay, and we should try and improve it where we can, because otherwise we'll drive ourselves nuts. You know, we have to, if we can change things from by trying to improve SAP, but the rest of the world out there, that's what they work to. And unfortunately, us saying forget about it, that won't help, because they're all their metrics that they've got, the things that they've got to hit, the targets that they've got to hit are based on EPCs. So let's try and improve the system that's there and take the opportunities when we can. So for example, in PAS 2035, the version that was implemented in April this year, you can use PHPP in there as an option, right? Now, how much that's been implemented, I don't know. I can think of a project that I'm involved in at the moment where I have suggested to the social landlord that that's the direction that they're going. And to be honest, it's completely alien to them, but that's the way that they need to go, because what they need to do is there's a difference between, one of their focuses is the tenant experience, and the building is problematic from a tenant experience point of view, but actually energy use intensity, PHPP, tackles the tenant experience, whereas the EPC rating doesn't, right? They can fling PVs on the roof, right, and get it all up to a band C, and wouldn't it all be hunky-dory? But they will still end up with complaints from the building occupiers about certain aspects of that building. So PHPP absolutely is poised to do certain things, but I think we have to recognize that we've got to, there are lots of people who don't understand PHPP, and they're not actually having to, their key performance indicators are not in PHPP, they're in a different language. So we need to talk their language and convert it to what they understand. So there is a way of doing it, but I wholly agree. The world should operate on PHPP.
Okay, thank you very much. I'm just going to go to a question that was asked in the chat. It's been kind of answered by someone else, but it would be interesting to hear what you think. Is best practice these days to do an air permeability test in advance of doing the retrofit design work?
Yeah, because it will really help you. If you are
I mean, it's kind of obvious from what you've been saying, but
yeah. I mean, literally, I've had situations where you can see the light bulb going on in somebody's head. I mean, I haven't talked about the course that I've put together to train. Basically, it's to train people who understand energy to use air tightness equipment and interpret buildings. Okay, so it's a hands-on course, and I did the pilot, and it was really for a group of half a dozen people. And what was really interesting was when they realized that practically they could reduce the airflow in a couple of buildings for a few £100, you know, by, you know, 30–40%, right? And it was this super draft proofing. It was the hole under the floor, or it was straightforward things. So if you as a specifier have a test done like that, you can see where the money should be spent. That's the whole point to it, because we need to, my driver is reducing carbon, and if we can get more people's confidence up so that they can put heat pumps in, that really makes a big difference from a carbon point of view. And this is a big factor. Air tightness is a big factor in whether there is confidence there or not, but it's all confused and in the pot at the moment. So we need to test buildings before retrofit. That's what it's all about, guys.
We've got a couple of questions about pulse air testing.
Yes.
One is saying, have you got any thoughts on the accuracy of pulse air testing? The other is saying, what is your view on pulse air testing as a substitute for the full blower door test? We're considering carrying out the former on our residential care homes. We'll shortly be working on, largely because we can't move the residents out during the test. However, I'm not entirely sure of their accuracy.
I could do a critique of accuracy of blower doors as well if you want, because
yes,
at the end of the day, they are bits of equipment that have been developed through an academic process, and that have a proven ability to put a number on how leaky a building is, right? So both tests are valid, and both tests have issues and inaccuracies. Okay, but they are both proven tests. Now, I focus on blower door. I've got experience of operating pulse equipment. I focus on blower door because the thing I'm interested in is understanding the building, as opposed to putting a number on it. And our current air tightness testing industry is there to put a number on the building, primarily to certify a new build house, right? But depends on what you're trying to get from your test. If you're trying to understand what you've got to guide a retrofit, a pulse test is easy to do, but it won't tell you where the problems are. It puts a number on it, but it doesn't help your understanding of the building. Can't hear you.
Because you could actually go around with a smoke wand and identify exactly where the problems are.
So the testing that I'm doing is I use infrared thermography usually, so that you can easily record what you are seeing in the building. So it's a combination of a blower door test and infrared thermography, allows you to understand what you have and record what you've got. And that's what it's all about. And you need to be able to interpret the building. But again, our current, and a normal air tightness tester is just used to putting an air tightness on that building, and doesn't necessarily have an understanding of buildings themselves, really. And you actually need to pull it all together. And if you do that, you've got a brilliant tool to facilitate good quality retrofit, because you know where you're starting from. You understand what you've got, so you can spend your hard-earned money on what is actually going to give you the best return on the capital, whatever the level of capital is that you've got.
Thank you very much. We've got a question here. I've just been trying to understand the question myself, actually, but it says, yes, the principle sounds right, but I'm not really getting it as to the different sort of specs you are going for in relation to these air tightness results. Well, presumably you've got all sorts of different specs you could be going for, depending on what you want to do with the building. You might have an ACB spec, but you have anything more to add about that?
Yeah, I mean, it really, I'm just reflecting what you've just said, Tim, in a bit more detail. I mean, people people have a wide range of expectations. They literally, they might have 200 quid to spend, or they might have 200,000 to spend on the property. Yeah. How can you spend that most effectively? And it might involve different sorts of materials, but actually, if you can cut people's, it's how do you spend whatever that amount of money is most effectively to get the best return on it. And I do tests for all sorts of depths of retrofit, and I'm always there's always something quite serious that you can pick up that would be really easy to solve for a minimal amount of cost. Slight diversion. The funniest one I can remember was I think he must have been a stockbroker or something, somewhere in West London, nice house overlooking a park. And he got quite excited when I sent him round the corner from his house to show him where the smoke was pouring out of a second floor bathroom, because there was just a big hole in the wall. And a 30 to 40 pound roll of air tightness tape would resolve that issue. It could be that. So it really does depend on, it might be a formal standard, or it might be, the constraint is the budget limit. It's good to put a number on things if it's a more in-depth retrofit, because then everybody's clearer about what you're talking about, because people hear different things, and it can be quite problematic sometimes that a client might say something, but a different specification heard by somebody else. So putting a number on it gets away from that vagary, really.
Good. Thank you. Going back to what you said about the pulse test a little bit earlier, someone's asked, is localization of sources of leakage more important than quantification of leakage, or in less airtightness, in less airtight buildings?
Yeah. So the question, just to make sure I'm clear about what the question is, is it more important to know what they are rather than how big they are? Is that what the question? Yeah.
Yes.
Okay.
Is the localization of sources, finding out where they are, more important than the quantification, the actual end figure in less airtight buildings?
It depends on what your objective is, because if you really you want to be looking at both. If you sort of think of a moderately deep retrofit, you really want to know both, because you want to know where the issues are. But if the figure that you get for the building puts you into a different zone, for example, when you're looking at ventilation, yeah. So if it takes it to a point where actually you need to consider a different sort of ventilation system, to say intermittent extract, then you really the ideal is to look at both, I would say. But it depends on, but really both.
I think we've got one more question that I could see from the chat.
Okay.
It looks like someone else has already answered it, but it would be interesting to know what your opinion on it would be. So someone says, thanks for the talk. What is the rough market price for air testing domestic properties? And is it possible we're at risk to making it becoming a barrier to making retrofits happen?
If you're looking at, yes, it could be a barrier. Yeah. Really, that people should just, it depends on people's perspective, really, because you've got to, it is a bespoke thing. Somebody has got to turn up and do a test. But you can see that, you could spend thousands on the wrong thing. I can think of an example where I tested a property that actually was quite leakier than it was expected to be, and the client had already spent thousands on specification, on a specification from a architectural professional, they'd spent hundreds of hours researching MVHR and triple glazing, whereas the house wasn't going to get anywhere near that, really. And if they'd spent, you know, £300 to £400 on getting a diagnostic air tightness test on a blower door plus infrared thermography, that would have saved them thousands. Yeah. But if you're any sort of project professional, it's the classic thing, you need to work out where you are now, and then you can design it and get to where you want to be. It's basic passive house stuff. So why aren't we just doing it? Why isn't it just part of the process? Because if you're looking at any expense, the risk of spending something on the wrong thing, it seems incredibly wasteful, both from a time and carbon point of view. So in terms of costs, yeah, £300-400. You're looking at, if you want to get somebody local to do one, I mean, what I'm talking about here is using a blower door combined with infrared thermography. You need to make sure somebody understands the building, because they may not be able to give you everything that you need. And I suppose that's why I'm going to give my course a plug, basically. That's why I've developed this course, because to me, there is a whacking great gap in the system, whether that's for the, one-off owner-occupied market, the past 2035 social housing stuff, or private landlords. And actually, we're at a really good point here, because the fact that the air tightness test can be put into EPCs, actually, people will be asking more about it. There's more of an incentive to people to do it, but it's a gap. Why aren't we just doing it? To me, it seems crazy. I can't work out why isn't already there in the system. It is. In past 2035, it says you should know what the air tightness of the building is before you start doing works. So past 2035 covers it, but nobody is currently doing it.
And the rough market price?
What, for the course?
No, for
the test.
For a test.
I'd say £300 to £400 if you've got somebody locally that does it. I could send you some more pricing information if anyone wants to get in touch. But if people are interested in training in this area, actually, to me, it really is such a gap that, I think we just want hundreds of people who understand energy doing these tests, because it's a key trigger point for helping people to get it right, the retrofit right. And I can't work out why we're not doing it, why it's not there.
And the number of tests we should probably do on a retrofit building.
Mm-hmm.
You're saying one to test the original building, obviously one to test the final thing, but how many in the middle?
I don't think. Why do you need one at the end, Tim, unless you're going for certification?
Well, if you're certifying a project, then you need one at the end. Yeah,
you do. But if you're not certifying it, which most projects aren't certified,
yeah,
you should. If you're only able, you should test it once the air tightness layer is complete, because everything is accessible at that point.
So that's your test in the middle that you're talking about.
Yeah. So you do a test.
Sorry, go on.
So work before you specify. I'm talking to specifiers in the audience. So you test it before you do anything. So you know what you've got. So the right things are specified. And then you test it when the air tightness layer is complete, unless you're going for certification or it's required for something. Testing at the end is nice to have, but the one that's good from a quality assurance point of view is the intermediate test. The one once the air tightness layer is complete is essential. Complete
but still exposed.
Yes, that's correct.
The important thing.
Yes.
Yeah. Because then you can do something about it. It's still accessible.
Yeah.
If you find
you sound like a salesman, Tim.
Oh, well. Yeah. Good.
We have had the question here. Can you tell us more about your course?
Yeah. Okay. So surprisingly, it's called Baselining Buildings. Okay. So yeah, it's called Baselining Buildings, and it's a 4-day course, and it teaches you how to use a blower door and infrared thermography. It assumes you know something about buildings already, but that you have never operated a blower door and infrared thermography. And there's an optional day at the end for you to train to produce certified airtightness tests that can be lodged under EPCs. So, and that's what Home Energy Doctor's doing. Basically, we need people who understand energy carrying out those tests. And yeah, get in touch, basically.
Great. Sounds very good.
Okay, well, thank you very much for inviting me to talk. I hope it's not been too much of a rant or soapbox.
It's been very interesting. No, airtightness is a core part of the standards, ACB standards, and we need to have some people come on with detailed knowledge of it. So it's really good. Been very interesting. Thank you very much.
Thank you very much, Tim.
So I don't think there are any more questions. So I think we're wrapping up there.
Great.
But
Thank
thanks
you
for coming, and see you next time.